Okay, so I was saying that this logistic regression, right? So the first thing you do is you create, what's the word? You create the object, which is this we are doing now. Now you see this stuff that is inside here. This we call these hyperparameters. That's what we call it. We call it hyperparameters. Can you see this? Now hyperparameters because you can change the values. You can change the values. Now, so we decided to create an object of this class. Now we decided to name it logistic model. Is it a must you have to use this name? No, you can use something else. But just at least anybody that sees logistic model already knows that what the algorithm we use there is logistic regression algorithm, right? That's the way it is. Now this is just for us to filter one. So yeah. Now this is the point when you do logistic model dot fit on that fit x and y. So this is the part where the model learns from the data. Can you see this? This is the part where the model learns from the data. You can see X train and Y train. So when you say dot fit, so every single algorithm will always have dot fit in it. It's common because when you say dot fit, it is the part where the model, which is why I wrote the point, is the part where the model learns from the data. So when you say dot fit X train, Y train, at this point, the model is learning from the data, right? If we should run this and run this, you can see this, right? Now, so the thing is, after the model has learned, now, then you've trained the model. So the next step will be to what test the model. Why are you testing? You want to be sure that the model has learned properly. Because if the model has learned properly, what happens? It means the performance is going to be high, right? The model does not learn anything at all. The performance will be low. So you need to what test it. Now, in order for us to test, now, which is that's why you already have the test set. Now just look at this scenario. Imagine which I think I was explaining something using was it maybe maths or something. So imagine for example, I come to the class. No, a maybe maths lecturer comes to the class and gives 10 examples, right? It gives each of these examples and explains that okay, for this particular example, this is an example of linear equation. This another example is an example of what quadratic equation, right? Now at the end of the class, right? At the end of the session rather, the lecturer gives an exercise. Now, don't forget that he has the solution to the exercise. Now, the reason why he gives the exercise is just to be sure that you fully understand what he taught in his class, right? Before leaving, right? Now, he gives you the exercise, maybe like 10 exercise or something, right? Then you submit it. Now, it's going to compare your answer with the original solution he has. That okay, question one, the answer is also linear regression. This person will for that equation fit, right? Something like that. So what it means is the model needs to make predictions so that we can now compare what it predicted for with the original answers fit what is lost, which is like the original values for what it predicted for, which is why you have to make predictions so you can still so predict X test, right? Now when you make predictions, now you want to compare like, okay, what you predicted for? Let me compare with the original results. The original, I'm using answers so I can easily be able to what I'm trying to see. So let's compare with the original stuff, the original value for what you predicted for, right? Now, which is where you say accuracy score. So Y test is what contains the original answer. This prediction is what the model predicted. So you're comparing the predictions from the model to what the result is supposed to be, right? Now, after running this, you can see that it's what? It's 6%. Now 0.x is when you convert it to percentage is what it's percent, right? You can see this. Let me try to explain this again. Now you can see here, the first thing you do is do this, create an object of the class, logistic regression class, right? You write the hyperparameters. After you are done, what next? The next thing is for you to what? That's when the model now learns from the data, right? So by doing what dot fit, X train, and Y train. Now, after it's done learning, in order for us to check out its performance, we need to tell you, okay, now predict the give us predictions for this set of inputs. So after giving predictions, you will now compare that, okay, now that you have given prediction, let me compare it with what the result is supposed to be, right? So we'll compare. Okay, after comparing, realize that the stuff is 86%, right? So you can see this, it makes prediction after making predictions. Then you now check the accuracy, right? You can see after checking the accuracy, you can see that we have 86%. 0.8 when you convert to percentage is what 86%. Let me just stop here to see if this is. I think you raised your hands, if I'm not mistaken. Okay, yes, please go ahead.
Yes, good morning, sir.
Yes, good morning.
That goes for that logistic regression that we have mass iteration. Is it
Yes.
necessary we make it or we can change it to like 20, 50, 100? You know, you call
Yes.
it parameters, right?
Yes, 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 yes. Yes, you can change it.
Okay,
So
so
yes.
continue,
So
sir.
yeah, so I said that you can actually change it, which is where I'm even going to. Where now you can see presently and we have it 60%, right? Now let's
Mm.
change this, right? That's what we call hyperparameter tuning. So I'm trying to run this again so that you see the difference, right? Coming on.
Okay, sir.
Yes. Let me do this again so you can see the difference. Okay, patient, just to answer your question, I'm coming. I'll check the chat shortly. I checked it just now, forgotten the question. A minute. Let me just quickly. Then this is the last one. Okay. Okay. So let me just put that here and just call this hyper hyperparameter to. Okay. So this is going to be okay. Let me check the chat. Okay, Pechi, just to yes, it's a library. So this warning is a library, right? The reason why you do this is because sometimes you might be working on something and it's not like the warning is an issue. It's just telling that okay, Victor, this feature you are using, they've they've created a new feature for this, so this is outdated. It's like just warning that they've changed it to, but you can still use it. It's just telling that Victor, don't forget they've changed this thing. It's now like instead of using this particular feature, they've created another feature that does something similar to this, like an update. So something like that. So just saying, Victor, they've changed this to like a one, right? But it's still gonna work. So in order for you not to just see that, which is why I said okay, not import warnings. They now say one is on filter one. So you are saying that ignore any warning you are supposed to show. I don't want to say any, just ignore it. I don't need to show me any warnings at all. Right. Now, so what I was talking about, right? Now, hyperparameter tuning. Now you can see in the first case we had 10, right? Now let's change this to 1000. Can you see this? We've changed the value from 10 to 1000. Now, let's see the results. Let's see what this is going to give us. It's still learning. Can you see that? Can you see that the accuracy has increased from 86% to what? Can you see to 90%? Can you see this? Just by changing this value from max iteration to 1000. Now we can still further increase this, but I'll stop here. You can increase this by adding
Yeah,
what's the
sorry.
yes, please.
For that random state, is
Yes.
42 always the constant?
No, no, you can use something else. Not you don't it's not a must have to. Let's change to 200 and see.
Okay,
Let's
sir.
change to 200. You can see it didn't really do much difference. So 42 is not always
Okay.
this thing. You can use any number you want to use. You can use 1000. So it's not a must you have to. You can see. So
Sorry,
I
sorry,
just
sir.
yes, please. Good.
Okay, this mass iterations
Iteration.
and iteration and random states. What is the
Yes.
implication? Is it based on the number of the data, or because I don't know, is it picking 1000 and running 22 of 42 of randomly of 1000 data collected? Because I just need to have the full meaning of
Okay.
what it means.
So now let's look at it like this. Now when you see mass iteration, so what it means is it's like the maximum number of iterations the server is allowed to perform. Now let me do this. So let's imagine that I'm trying to think of a very practical scenario I can give. Okay, good. Now let's imagine that you are trying to read something. Maybe you are going through goods. Now, let's say you're trying to read something, right? Let's say you are going through, maybe you are preparing for a professional exam and you have past questions, right? And let's say you have maybe 100 questions, for example. Let's say you have 100 questions, right? Now, that 100 questions. Now, you can decide to read everything at once, right? Like just going through everything at once. Now let's imagine that scenario compared to the scenario where I see that okay, you know what? 30 minutes, I'll use 30 minutes to go through some questions, just 10 questions. So that will mean that I'm going to the past question how many times? That will mean I'm going to the past question 10 times. Right? Let me explain again. You have 100 questions. Now you can go to that 100 questions at once, just reading through it, okay, at that particular time. But what if you decide to divide it into different sessions? Okay, I'll dedicate the first 30 minutes, I'll go through the first 10 questions. Now rest. After 30 minutes, you go through another 10 questions. Now you can see that you're going to go through that past question 10 times. Now, if you compare those two scenarios, you're more likely to remember some of the questions you saw in that past compared to when you read it everything at once. Because when you go through it when you go to the first 10 questions in 30 minutes, there's still room for you to look at it. Okay, looking at this first 10 questions, I can still revise that first 10 questions in that same 30 minutes. You know what I'm trying to say? So it means that you've already divided into like different sessions. First 30 minutes, I'm looking at this first 10 questions. I'll try to master the first 10 questions. Then when I'm done, move to the next 10 questions. When I'm done, move to the next 10 questions. Guys, so it means you're going to that past question how many times? 10 times. Because we said 30 minutes for 10 questions, 30 minutes for 10 questions, 30 minutes for 10 questions. So which means you are iterating 10 times. It gets so when you say maximum iteration, it's like saying from 10 to 1,000 times. Now it's like no amount of time you can actually go to that same thing. So imagine you are telling to go to that same thing 1,000 times. Just give me an example. Now there's AI tendency is able to master that stuff more compared to when you just go through that stuff 10 times. I don't know if this illustration driving what I'm trying to say to you.
Yes,
So
I get you now. Can you relate it to this 1042, sir?
sorry?
The illustration now, can you relate it to
Yes.
this 1042?
Okay. So let me try to illustrate it to you. Now initially I used my citation equals to 10, which means that I need to go through this thing 10 times. Like go through the stuff 10. Remember, this stuff. Look at this. This is the algorithm and it's learning. So it's like saying I want you to go through to learn this thing 10 times. You go through it the first time, learning the first time, learning the second time, learning the third time. So it means you're learning it, you're going through, it's like you're revising it 10 times, right? Now compare this to a scenario where this algorithm is learning, it's going through this thing over like 1,000 times. You know there's every high tendency that it's going to give a better result compared to when you go to stop 10 times. Just like saying, I'm preparing for a professional exam. Then someone asks me, how many times did you go to the past question? Bro, not just 10 times. And someone now tells me, I went through this past question like 100 times. So there's every high tendency that you most likely master the question and the answer. I don't know if you get what I'm trying to say. So, I don't know if I drive what I'm trying to say.
Yes, I do. Thank you.
Okay. So that's what the mass situation does, right? So yes, that's what we do. So you can see, let me increase it from 10. Okay, yes.
Does that mean that the more the numbers of iteration, the more accurate the model will be?
So the thing is there's actually a bot, right? The bot is you might increase the number of iterations and you might not really do anything again. Do you understand? Because just like saying, let's just look at it. For example, I go to something 1,000 times and I want to go through that same stuff 10,000. Like I'll get tired of it, sometimes. So it might not really make any much difference actually. So, but what I'm saying is when you increase that first, there's going to be a difference. But I'm saying that if you go further to still increase it, it doesn't necessarily mean that you still like there's not always a 100% guarantee that it's going to increase the accuracy again. Like for example, now it was 10, I increased it to 1,000. Now I'm now also trying to increase it to go beyond that. It's just like that, which is why I say let's just try to relate. Imagine me preparing for an exam, and I've gone through this past question 1,000 times. So even when I now say okay, I want to go through it 2,000 times, which is not possible. I'm just giving an example. I already get tired. I don't already know this thing, so there's really no point going through this thing. I don't know if you get what I'm trying to say. So I'm saying like there's always that 100% guarantee. There's always case, especially when you increase like 10, 100 years, when you get to 1,000, it's just best that you just stop there. Now even when you go, even when you go ahead to increase it, you might not see much difference. I don't know if you get what I'm trying to say. I'm saying like there's not always a 100% guarantee that okay, when you increase it, the accuracy is going to increase. I don't know if you get what I'm trying to say. It's like saying we'll try
Yes.
something, check the result. Okay, let's try again. So I'm saying if you could increase this thing again, I just realized that there's really not much difference. You can try and see.
Yes. So for us to be able to get the best one, we have to do all this trial and error
Yes,
method.
yes, good. Now you get now. Yeah, that's why it's try and error method. You try this, see the results. Go back again, try this, see the results. And that's just the way it is.
Okay, thank you, sir.
Yes. Is there any other question, please? Okay, so if it is clear, please just drop one in the chat so that I can continue. If I is talked about, so if it is clear, please just drop 1,000 in the chat. I say 1,000. Drop one in the chat. Sorry. Okay. So you can also scale now. I'm just let me just keep this in, right? Now, you see for logistic regression, when you scale your data, you're also more likely to also increase the what's the word? You're also more likely to increase the accuracy. Let me just do that. So I'm sure that I'm done with logistic regression. I'm trying to do something else again. So let me just permit me. It's still the same thing. I'm just trying to add something else again. There's no need for time. Okay. A minute. I'm trying to copy everything again and do something. Okay. Okay, so let me just call this iPad parameters. Power parameters too. Sorry, please, we are supposed to go for a short break. Just a minute. I just want to quickly do this. Okay. So let me just do this. Now, there's something called scalar, where you can also like sort of like scale your data. Sorry, let me just. Please permit me to just write it so it's easy for me to just explain everything at one. Standard scalar. Sorry. I'm trying to write everything as one. So I can easily explain. Okay. So I just want to. Okay. So I'm just trying to do everything at once so I can easily just explain. What else extra? Okay. Okay. I think this server should work, I guess. Okay, let me check. Scalar, transform, scalar. Okay, let's come on here. What else? My test. Okay, so now let me explain what I'm trying to do. Now, I think before now, Bola actually asked the question that when you have numerical columns, so if you are including categorical columns, that will mean that we are also not including numerical columns. And the answer is yes, right? Now, you scale your column. Now, I think before now, I think I explained why you scale sometimes because Your data could have outlier. I think I explained that. That's if, for example, now I have, let's say, I have I'm working with data that contains information about students in maybe junior, let me see GSS1, for example. And I'm seeing age like 9, maybe 12, maybe 11, maybe 10. Then I also an age that is 80, for example. That's weird, right? Or let's say I saw 100, for example. That's weird. So it's most likely that I'm just going, maybe it's most likely that maybe the person wanted to enter 10. And there was not a mistake of entering 100 because it's weird for you to see 100 person in JS. I'm just giving an example, right? Now, so if you look at this, now this is going to affect, because don't forget that the model learns the patterns. It's going to affect the result because 9, 12, 11, 10, and then it's now 100. Look at, you can see the gap is that now this is like an outlier, right? Now when you scale, I'm just giving it, so when you scale your data, instead of it coming like, it could be like 0.2. I'm just trying to explain it in the best way possible. This is 0.2. So let's say you have, if after arranging this, you have 9, maybe 10, 11, 100. Okay, I think 12, right? So I'm just trying to explain something. So now after scaling, it could be 0.1, 0.2, 0.3, 0.4, and 0.5. Can you see that? Can you see? So you can see now we don't have any issue. I'm just giving an example. We don't have any issue because we literally like scaled it from the way it is now to just the way it is now, right? Trying to explain something. No, so which is why, so you see, for categorical, you encode categorical. Why for numerical, you scale? You scale numerical, right? And let me just try to. So now, for logical regression, it's always advisable that you scale, right? Scale your, so after encoding, know your data, try to scale your data before giving to logical regression. Why? Because when you scale your data, right, you get a better result from logistic regression. That's just the truth. So which is why you can see here how to import standard scalar. See, so sorry, just 2 minutes. I know you're supposed to go for a short break, but just quickly, just to quickly do this. Okay. So yeah, we decided to import standard scalar, right? Which is like a library that we use to scale. You know, as usual, what are we going to do? Create an object. Let me just try to run this. We create an object of the standard scalar class. Remember, you're only applying scalar to numerical. Now, the why will you scale it? No, because remember it's just going to be 0 and 1. The only thing we are scaling is the input feature, not the target. So which is why you can see I'm only scaling X train and X test. You're not scaling the Y train and Y test. Why? That's what you are predicting for. You are not scaling it. You're only scaling the input, what you are giving to the model. You understand? So let me check the chart. Okay, so the thing is, by 11
Church
6,
break is 12 o'clock. 12 to 12:15.
sorry. So the
Church
thing,
break is 12
okay,
to 12:15.
okay, so the thing is, because of the, what's the word? Because of the mixed class on, I think I announced it yesterday that soft skills session class will start from 11:15 today, which is why I said 11 to 11:15 will be for short break. I think I mentioned it yesterday, if I'm not mistaken. So that's why. Because the soft skills, because we mixed December 20 class for soft skills on, that's December 20, so which is why today instead of starting by 12:15 to start by 11:15. That's just the thing with it itself, right? Okay, so let's continue, right? So you can see here we import standard scalar. We have to create an object of the standard scalar class. Now you can, now fit transform. This is not the person you're saying this. So what it means is understand the data so you can transform it, right? So you do that for train. You also do that for tests. If I should run this, see me, I wrote standard scalar. Let me just change this thing. So you do that for X train, X test. Can you see this? Now this solver, how do I explain this? Right. So the way logistic regression works is logistic regression, it actually uses algorithm to find the best coefficient for your features. For your features to mean, features, that will mean your columns number. We call it features. Features means columns, right? But this is machine learning, so we call it features, right? So if I say columns, you already know it's features, right? So it looks for the best coefficient for your features. That's what. So it uses different algorithms. I think there's um Leap Linear, there's Saga. I think there's one other one like that, right? But like I said, you don't necessarily have to master all of these things. That's why you always have documentation on the site. So basically just look at, I'll most likely drop the documentation for these different algorithms. So you can just see different things. Just for it. You don't necessarily need to know everything. You most likely have documentation on the site, right? Because even myself, sometimes I forget some things. So which is why you always have documentation on the site so that if I forget anything, I can just look in the documentation and just say, okay, this is what I forgot or something, right? So logic regression using different algorithms to like learn. You understand? So this is what we are using, this leaf linear, right? So if I run this, you can see because I've scaled this train, which is why you can see I'm still going to explain this again. I'm going to run this. You can see, then I'm going to also run this, then run this. Can you see that the accuracy has increased? Before it was, can you see 90.1? Now it's 90.3 approximately. Do you understand? Right. Let me try to explain it again. Yeah, we decide to skip your data, right? So you can see we scaled it. Sorry. We decide to scale your data. You can see this here. We scale the data. Then yeah, after sorry, we decided to create an object of this external scalar class. Then yeah, what we did was, you're trying to scale your data, which means you're scaling the X string, you're also scaling the X test, right? Scale X string, scale X test, which is why you can see you have X string underscore scaled, then S test underscore what scaled. You can see this, right? Then yeah, it's just we just creating a logic for the logistic regression class. You can see this, right? Then this is where the model tends to learn. Now, instead of us saying X string, we can't use the X string here. Why? Because we've already scaled it. So we are using what we've scaled already, which is what X string underscore scaled. Can you see this? Right? So you can see similar to this. So instead of you writing X test, we'll now write X test underscore scaled. Because we know we've scaled X string and we've scaled X test. So going forward, what you're going to be working with is X string scaled, X test scaled, which is why you can see fit. So it means X string scaled with Y. Yet you are trying to predict the result for X test scaled. Remember, we've scaled this to itself. Then you just check the accuracy. You can see the accuracy has increased from 90.1 to like 90.3 approximately. Right. Let me just stop here to see if anybody has any question. Please, if this is not clear, just let me know so that I can go over this again.
It's not
Probably.
clear to me. It's not
Because
clear. I don't understand the standard. What do you call it? The standard scalar
Standard scalar,
survival.
yes.
Yes,
Oh,
I
okay.
don't
I'm
understand.
not just, it's not like, sorry, it's not like me, I don't know machine learning, but I'm just trying to, this one, we're always writing everything together, but this one that you broke it down is making everything just look somehow.
Look
So,
somehow. Okay.
yeah, like, I'm just lost. I swear, I won't lie, like, since it started, I'm just, what's happening?
Okay, so let's do this. Is it okay if you just go over this again after the soft skill session? Is that okay, please?
Okay,
Yeah,
that's
it's
fine.
okay, sir. Sir,
Okay.
please, you explain this lib linear very well with standard scalar. I don't
Okay,
understand
okay.
it.
Okay. I will explain to you. I'll explain to you. Thank you. Yes. Okay.